Hey guys, welcome back to Algos Explained. My name is David Kim, and in this video, we're going to be going through a JavaScript question on Code Wars. And what we do here is we just go over this algorithm question that is provided to us through Code Wars, and we're going to walk through it together and solve it together. And as I do that, I'll give you guys just kind of my thought process throughout the whole thing. And so this is a level 7 question, as we can see up here. And that means it's kind of easy still, but not the easiest that we can see on this platform. But anyways, let's go ahead and get started. This one's called Deodorant Evaporator. This program tests the life of an evaporator containing a gas. We know the content of the evaporator, content in milliliter, the percentage of foam or gas lost every day, and the threshold and percentage beyond which the evaporator is no longer useful. All numbers are strictly positive, that's okay. The program reports the nth day as an integer on which the evaporator will be out of use. Content in note. Oh, okay, here's a note. Content is in fact not necessary in the body of the function evaporator. You can use it or not use it as you wish. Some people might prefer to reason with content, some other with percentages, some others with percentages only. It's up to you, but you must keep it as a parameter because the tests have it as an argument. Okay, cool. So that's kind of a little bonus that we got. They didn't have to tell us that, but they did. And that means that we have three arguments here, three parameters here. And we don't really need to use this one. Some people do, some people don't, but we don't have to. So let's go ahead and kind of make sense of this. This was a pretty wordy question, so you might be thinking, okay, um, which words, which portions of the problem do I focus on? And let's think about this. First of all, I've noticed that they started out with deodorant evaporator, but this question has nothing to do with deodorant at all. So maybe the writer of this question was trying to go a deodorant route, but decided not to, and they just never erased that. But anyways, I digress. It looks as if what's going on here is we have a can of something, maybe a can of aerosol, and we use a certain we it's explained here that it evaporates every day, but we could also think of it as kind of we use it every day, the same exact percentage, and that's another important thing to realize here. We're using a percentage of the bottle, and kind of the threshold at which it's no longer useful is also a percentage, and you have to understand that that percentage of the threshold, or that threshold percentage, is talking about the percentage of the can when it was full, not the percentage of kind of the current level is going to be at any given time. And so we know that we have to do some math, we need to do some comparisons, we need to know, okay, we need to subtract kind of what's used every day, and we have to compare that with that useful percentage. And so how do we do that? We are going to, well, while doing that, we need to keep track of kind of how many days have passed. And so we're not going to return -1 here. That's just, they didn't even have to put that in, but whatever. What we are going to do is we know that in the end, we're going to have to return a number of days that we went through. And so let's go ahead and start out with that. Days 0, return days. And so we know that in our logic, we're going to be kind of calculating something here and there. And in the end, incrementing days by how many times maybe a loop goes through, and we're going to be spitting out that days for us. And so we created those variables for ourselves, and let's see, let's get a hold of kind of some variables that we're going to need. We're going to need kind of the current level. We know a current level of the container, and I guess here is kind of where the content comes into play or doesn't come into play. We could use the content as that whole, or we could just use the number 100. And I chose to use the number 100 because we're dealing with percentages here, and whenever we're dealing with percentages, and if I can use the number 100, I do, because it's just so much easier for me to kind of visually see it, and see it in my head. What is going to happen is we have to know, okay, of that 100, say that's like 100 milliliters. It doesn't matter, but if say that's 100 milliliters, and we know at a certain threshold, this container is no longer useful, and so we can't compare it to the threshold percentage though, because that is just a percentage. we need a hard number, and so let's do that calculation right now. So our lowest level is going to be kind of 100 times the threshold times 0.1, because we're just going to make it into a percentage right here. And so we know that, okay, current level is going to be subtracted by something, is going to be subtracted by the percentage of use every day. But once it hits this new lowest level, which has been pre-calculated at the very start, we are going to kind of end it right there. And so I think using a while loop is going to be the best, just because we don't have a complete kind of hard line of when we're going to stop. And that's kind of the big distinction that I make between while loops and for loops. For loops, you know, kind of maybe you're iterating through an array. You know that the array is going to stop at some point, and so we have that. You know how maybe that first parameter is kind of initializing the variable. Maybe you let I equal 0, and the next one is kind of as long as I is less than array.length, something like that. That's kind of great to use a for loop for, because you know when something's going to end. You know at some point it's going to have to end. And of course, you don't want these loops to be going forever, but for a while loop, you're not sure when that endpoint is going to be. It could be at 100, it could be at 2, 4, 5 loops in, and you get the point. A while loop doesn't have that distinct end in sight. And so, like the situation, we're not sure when it's going to, we're not sure when exactly it's going to end. So we're going to create a while loop, and we're going to say, as long as the current level, because that current level is what's going to be constantly changing, as long as that's greater than or equal to the lowest level. So as long as we determine that, yes, it is still useful, this can of spray or whatnot, whatever we have, as long as it is still useful, we are going to go to loop one more time. And so what happens when the loop passes? That means that 1 day has passed. So we're going to increment days, and we're also going to, this is very important, we're going to decrement the current level by something. And if we don't decrement current level, it's never going to hit lowest level, and therefore it's going to create an infinite loop. And so now the question is, what are we going to decrement current level by? And we're going to decrement current level by the percentage used every day. And so how do we calculate the percentage used every day? We take that, we take current level, and we find out how much is used that day. And because evaporation per day is a percentage, we have to take the percentage of the current level. And so I know I kind of referenced this to kind of being used every day, that unless you can exactly use a specific percentage every day, that wouldn't really make sense. It makes more sense when I said usage every day, that the evaporation per day would be a hard number, but this is a percentage, so it is indeed kind of evaporating per day, kind of, yeah. Anyways, you get the math. What we're going to have to do right now, we're going to have to calculate the current level at a percentage. Current level. And so we're going to have to find out how much evaporated that day. And so evap per day, we're going to use that. And we're just going to turn that into a percentage. Oops, too many of those. Okay, I think that's enough parentheses. Okay, so what we did here in the while loop, just to reiterate, the while loop is going to constantly loop around as long as our current level is greater than the lowest level, which means lowest level is, don't use this can anymore, is useless because too much of it evaporated through time. As long as our current level is greater than that, we're good to pick up that ball and use it every time, but for the purposes of this function, we're acting as if the can was never touched. And so every time the while loop rolls, another day has passed, and another percentage of the kind of the gas in the can evaporated. And so the percentage of the gas evaporated, we calculate that by taking that current level, which starts at 100, and we take away evaporation per day. And don't be confused by this. We are doing this calculation just like up here because they give us a hard number here. So when they give us 10, that represents 10%. They could have given it to us in percentage form, but they didn't. And so it's up to us to make that into a percentage form. And so we're just calculating that. So say for example, here it is 10%. What we're going to be doing is we're going to be decrementing current level by 10. and at the next loop we're going to be decrementing it by 9, and at the next level whatever is 10% of 90, something like that. And so as we incremented days, that should have done that trick. And so let's go ahead and attempt this. Cool, and so that passes. And so like I've been doing recently with my videos here, I'm going to upload that file that I used to solve this question into a GitHub repo, and I'll have that repo description in the description. Feel free to fork it and add your own solution to it if you want, or not. Just watch this video. But anyways, if you liked this video, if it helped you, like, comment, and subscribe, and check out my other videos. Catch you later.